And today I have a pleasure of giving the floor to Professor Trofim Maksimov, who's actually been doing incredibly interesting work for so many years now on the impact of the local permafrost regions to the world climate, global climate. So thank you very much, Dr. Patrick Lam. So now we're giving the floor to Professor Trofim Maksimov. Thank you.
Thank you, Vasily. Thank you for inviting me. Good afternoon, everyone. What place is better? Over there? Time is not so limited. Yeah, it's good for me. Yeah. My name is Trofim Maksimov. I am from Siberian branch from Russian Academy of Science. And also I am scientific supervisor and principal investigator of more than 50 international projects with 18 countries during 30 years. I would like to give my lecture about the role of permafrost ecosystem in global climate change. What kind of investigations were carried out in this very big territory of in northeastern of Russia with foreign scientists. And in the beginning, I would like to show this picture about the changing of climate during 71 years on global climate change. Red colors showing the increasing and blue is decreasing of air temperature in this side. Definitely, we are staying now in the period of global warming, and this phenomenon is more intensively growing in Arctic regions, in high latitude ecosystems. This figure shows from IPCC reports. This figure shows how to will be with temperature and air precipitation amount in the future in Arctic regions. And we are now every scientist is talking about the global warming. Very strong depends of seasons. This shows figure shows how to change of change temperature air in winter time. Nevertheless, the last the last 50 years, this phenomenon, not global warming phenomenon, not so depends from seasons. In any seasons, in summer, in springtime, autumn time, and winter time is increasing now. And when we carry out in this place investigations, the role of regional climate to global climate change, with from and influence of high latitude ecosystems for this climate change, due to how to change of water and energy exchange, and also how to change the greenhouse radioactive gases to the regional and global scales, and also how much of carbon and also some trace elements is delivered from our main rivers to Arctic oceans. According to these obtained results, more than 75% of emissions from greenhouse gases is gives to CO2, carbon dioxide, and more than 18% to methane, and also few amounts contribution of another gases, for example, nitrogen oxides, and also gases from industrial origins, and also some freons and ozones, very strong impact to greenhouse effect for global warming. According last year's results, concentration of greenhouse gases very strong depends with increasing of high latitude. With increasing high latitude, of course, due to physical properties of these gases, is the concentration of greenhouses increasing. We carry out in this place using some aircraft measurements from on the different heights of this land. We carry an aircraft in the way aircraft investigations. This figure shows our measurements in 6 profiles of the concentration of greenhouse gases, five kinds of greenhouses. This one includes CO2, methane, and nutrient, oxygen, and so on. Yeah, and also we found very strong year by year now increasing of CO2 greenhouse concentration in this land. Not only regional scales, also including global scales. Our height measurements levels is about 3 kilometers. This is how to say it's global scale. For example, for this using these measurements, we can estimate and make some upscaling measurements for big territory. For example, on the global scale. Yeah, this one also include last year's experiments with CO2 gases, carbon oxygens, main greenhouses. Every year, 1 year's growing excrements about 1.2 ppm. Year by year, it's now we have trend with increasing of CO2. According global warming now is increasing also not only impact not only for air also for permafrost. This figure shows the increasing of permafrost in different countries in different periodical and climatical zone. This one include not only our republic and also including North America, in some Canada, and Asia, and many countries. And in last 40 years, the size of permafrost area is decreased about 40%. It's very serious problems for climate, for us, for our populations. And with climate change also increasing the active layer, it's sowing and melting periods is very important for plants. It's year by year, it's another increase in also active layer place. For example, in some place we can find in the central parts, some place non-frozen in winter time. It's very serious problems. Then we will carry out our investigation in main representative ecosystems. This figure shows the disturbance of our species trees in Russia. Brown color means it is main dominant species is larix, large trees. It's more than 60% of our Russia is carried by large species. Second, red pine trees is more around 70% of this territory. And second, more representative biomes, which will be impact in will be have big contribution to the global warming is Tundra ecosystems. This figure shows the distribution of tundra sites in these regions. Also, we don't forget also about another ecosystem represented. This is forest tundra ecosystems. It's boundary and transition zone between tundra and forest. In this territory is concentrates a lot of amount of carbon in the soil and in the permafrost and also in the plants. About 25% of carbon in Russia is concentrated in this place. It's very important. Also, this place is a very good place for sequestrations, for assimilations, for sinking of carbon, because we have green plants in this place. Basically, of course, large forest. And this figure shows our last data about air temperature trends, which I already told you, not so strong, depends from season. Any year, you can find this impact, not only in winter time, like in which was introduced in IPCC reports. And also, now it's changing also the period of freezing and thawing, and also in changing of growing seasons for the plants. Is year by now is increasing growing season for photosynthesis process. And second, also same entourage concerning of precipitation amount, also increasing year by year. And according to this increasing of precipitation amounts, we can find very huge floodings area in northeastern of Russia, in our land. This figure shows publication which was published in very peer-reviewed international journals and in Nature. It was about last 50 years, the size of water and wastewater is increasing 12 and 15%. And this flooding is a very strong impact also for life of our trees. Our trees die. And because too much water is very bad impact to the roots of root systems of plants, and all trees is died. And also we have very old mature trees. That trees is not so good, sensitive and tolerance to the wet condition. Nevertheless, of course, this is water-like species of plants. This figures also some same phenomena on the right side of Lena River on the way to Churapcha. You can find this is impact of decreasing of precipitation amount and becoming with dry seasons now. And also, we don't forget about the impact of insects in this place, and also impact of forest fire in this place. Global warming also impact to some, so for the infrastructure of our villages, you can see some impact to our road and also for our villages. Now it's very difficult to some place to find good and reliable place for construction of new buildings. every 10 years, you can change place from one side to, it is very big problems for the local populations. And also some pictures about some landslides on the way to Amgari, which was in 213th. This is some example of soil erosions in this place. More than 3 kilometers of roads was completely destroyed. Yeah, and it was big. It was a very big economical and financial expenditure for local government. Yeah, and also this figure shows some formation with global warming and formation of Allah's ecosystem in with after forest fire, after cutting of plots, after cutting of trees, and after land use, beginning some process with formation of Allah's ecosystem, with low productivity of grasses in this land, and very difficult for facilities of local people in this place. They can find more better place for life. And this is some stages of formation of the thermocast processes on the right side of Elena River. Yeah, maybe you know, in opposite side, a lot of place, Allah's ecosystem place. And this changing of climate is global warming, also changing the number of species of plants and animals in this place. According our result during 70 years, the number of, for example, vesicular species, changed. For example, if in 1935 we found only 1,200 species, so now we found 1,800 species. More than 700 species, new species we found. It's very interesting. And also this one, for example, I would like to show all the main species which we can to find in the forest, because, for example, for investigation another small species, for Moses lichens or so on, very difficult, yeah, because very big territory, and our methods is not usable for clarify how much and estimate how much species we can find. And concerning of mammals, also, for example, during 70 years, we found more than 30 new species. 2 times is the number of mammals increasing here. Moving some species, places, southern plants moving to the north, and also trees, large trees also moving, progressing to the north. Tree lines now changing. Yeah, it's a very interesting phenomena, and also you can find, for example, very good expansion of and progression of some shrubs in Arctic, in Tundra side. Yeah, it's concerning of our result with forest fire. We prepared some speculative scheme for depend of type of forest fire, surface fire, and ground fire, underground fire, and another abnormal long fire. It depends of type of forest. You can we can find how to build with regeneration process in this place. In some place, very difficult for regenerations, but in some place possible. Concerning of large forests, Now, usually is occurred in large forests is surface fire. It's not so bad for this forest. And now is, for example, I already told you we have very mature forests, very old forests, more than 75% of 47% of our forest is mature forest. And this is very good fuel for forest fire. And after forest fire is emitted a lot of greenhouse gases into atmosphere. This figure shows how much of emitted carbon into atmosphere. It's, for example, in 1998 was one of the strongest fire in Russia, same in these periods. In that period was emitted a lot of greenhouse gases. Now we're living the period of decarbonizations of countries. We must be ready to carbon tax. Will be the period for sailing and the delivering of carbon. Any country will be very strong delivering periods, sailing periods for between countries. Yeah, and I'm afraid, for example, after this year's fire, we will pay big amount of money for European Union. Yeah, it's definitely our land is sink of carbon, but we have now we have big expenditure with forest fire. We emitted a big amount of greenhouse gases into atmosphere. Yeah, I already told some species is moving to the north. For this figure shows some species they have special C4 pathway photosynthesis. They're moving to the north. This is one of the pioneer species for this land. This shows some what kind of a species is moving to the north. This one including that species, C4 pathway photosynthesis species. And also now some new species we found in our place. For example, during my investigation in Spasskaya Pat experimental forest station near Yakutsk, this area is located in the north of our city, 30 kilometers far, and we found new species, Rhizopogon laricinum. This is Корневец лиственничный. Nevertheless, it's very interesting. That mushroom has master pine trees, but now changed to large. It's very interesting. In new species we found, we use some special biological methods with Japanese. And also new insects coming. It also this is, for example, zinc-bound encephalid. Yeah, we found also in our experimental stations in central Yakutia, very close from city now. And after global warming and year by year is increasing the hotspots, extinctions in the world. This was include not only Siberian tundra, some species also disappear in this place, and some species is growing and expand in this place. But also this one includes also some northern part of America in northern Canada, and so on. And we made some scheme about how to global warming to impact for vegetations. For example, this is from secular, how to, for example, in high latitude warming is very strong impact for increasing of shrubs in tundra site, for example, and very strong impact for changing of permafrost soil. Permafrost is melting. And also, after melting is emitted a lot of hazardous gases. This one beginning some back process in change to high latitude ecosystem warming. And also increasing of shrubs, very strong increasing to very strong impact to decreasing of albedo. And also for very strong info for increasing net radiations. And also to very strong impact for atmospheric heating, global warming, yeah? And after that, again, return to beginning of melting periods and so on. And we were began our field work with in international projects on global warming in 1991 first, together with University of Hokkaido and also Forest and Forestry Products Institute from Sapporo for investigation of impact of changing of climate to atmosphere, biosphere, hydrosphere, and lithosphere of these regions. At first, we began our field work on this territory. It was very serious. We had big expenditure. We lost a lot of amount of money for 5 years. After that, we decided to starting new monitoring studies in our scientific stations. And then we established serial experimental site in these regions. This figure shows our experimental site in central Yakutia, in southern part of Yakutia, in moderate productivity and large productivity of large forests. And also we established station also in tundra side. Now, and also in finally, we established 4 station in forest tundra ecosystems. Now we one of the leader. Now this works network we are calling Saha FluxNet. Flux measurement of energy, heat, flux measurement of water, and flux measurement of the carbon flux. This one including CO, carbon dioxide, and methane. Yeah, meaning flux, Saha Flux network. And now we are one of the leader. I told you not only for that's all. What happened? No? We are leader not only in this number of amount of experimental site station in this place, but also including with our instrumentary base. We have a lot of devices and equipments for investigations, and also this one also included the number of measurement values. What kind of a lot of scientific parameters we have investigated. And then the main purpose of this experimental station is to carry out interdisciplinarity scientific research to address fundamental issues that reveal to the complete real picture of the status of environment, the nature of the interaction of the all parts of, for example, atmosphere, biosphere, hydrosphere, and cryosphere. One station is working like small institutes. We have very big projects, very big cooperations, and very high complex and multidisciplinary study in each stations. We are using 4M methodology for our research on climate change, on local, regional, and global scales. For example, 1M is monitoring. We will carry out investigations on flux measurements and climate measurements using satellites, using aircraft, using flux tower, big tall towers, and also using terrestrial surface investigations. 2M, this is manipulation, some experiments with possibility global warming scenarios, including a forest fire, surface forest fire, dominated forest fire, and also with changing of precipitations amount. And also using our many unique and very big data set. We are using some mathematic models for predictions how will be with our ecosystems, representative ecosystems in northeastern of Russia in the future. And then finally, of course, for M, this is some management. We would like to combine our scientific knowledge with society and also with stakeholders, including some policy makers or so on. In this place, we will carry, this is a location of our stations. This some, I would like to show this our horizontal experiments from from south to the north, distance about the length of distance about 1,100 kilometers, and included representative permafrost ecosystem, large, high productivity large forest algae station in Usmaya, Spasskaya Patch station in moderate productivity of forest in central Yakutia, and also forest Tundra station and Tundra stations. This is some horizontal. It's a very big area. And also, in this place, we carry out investigation using some satellite measurements. We are using remote sensing measurements and also terrestrial surface measurements for estimation of vegetation type for each biomes. This is very important for upscaling our obtained result, for example, on greenhouse gases, on carbon, on nitrogen, and so on. Then also we are carrying out investigation in the laboratory. We cultivated our Yakutian trees in the laboratory, and we are measure some physiological biochemical processes, how it will be with photosynthesis and with respiration of plants in the future, how will be in the future with productivity of forests. And also we have some surface terrestrial observation, field work near tower site, very big tall tower site, for investigation and for estimation for all components of carbon and nitrogen in ecosystems, including air, including air, including vegetation levels, including soil levels and also permafrost. And also, of course, also we're using some mathematical models. After using this one, this is very important for scaling and for estimation and for the focus of carbon budget and nitrogen budget for these regions. About our vertical investigation, I already told about horizontal, more than 1,000 kilometers. But then also we have some profile measurement from space to permafrost for lithosphere, lithosphere. We are using some satellites, NASA Aqua satellites, and also Japanese JASA satellites for our investigations. Then we are using some aerovisual, we are using aircraft, for example, Il-18 and 2 drones, yes, aircraft and so on, this aerostat in this place. We have also some land surface measurements. This is including some big tower. We have tower site. This is our tower. It's with height 33 meters height. Near Yakutsk Spasskaya Pass, for example, we have 6 tower sites. And also we study land, including soil and permafrost. We are calling this is investigations of Sahara network. Yeah, this is our main station, which was established 70 years ago. This is one of the first Russian experimental forests. In this station, we have 70 years inventory data about productivity of this forest. Depends of vegetation type and depends of tree species. It's good for modeling and also for investigation. We can find very reliable and exclusive place for installation of our flux towers for the measurements. And from 1991, we began our flux measurements with Japanese, then with European Union in this place. And second station was established in 2003 in Tundra with Dutch scientists from Netherlands. We have some mast, not tower side, but of course, height of vegetation is not so wide. We don't use big tower side. It's only 6 meters tower is enough for this place, for excellent footprints for upscaling. Together with Dutch scientists, yeah. This place for crane, yeah, Catholic side. And so first such station, Elgai station, not Suntar. This is in Usmaya regions, yes, another one. Yeah, it's Eventian name, yeah. Eventian, yeah. Event name, this means center of land. Yeah, Elgai, yeah. We are also established with Japanese in this site, very high productivity of forest, very beautiful place. And also in Finland, we are established also with Japanese in one station in forest Tundra site, yeah, from 2011. Now we have very excellent, very good experimental site with good maintenance. Yeah, with high amount of money, of course. We are supported with not from Russia. We have international projects. Yeah, and these are our measurements on plant levels for study of photosynthesis process. Yeah, carbon dioxide uptake, and also some respirations measurements. We are carrying our field work not only here in Russia, Also, we carry out in our investigation in US, in Canada, and so on. It depends of our grants. And also, we measure some soil respiration, how much of carbon dioxide and methane is emitted from soils. It's also very interesting problems. And also, we carry out some very high quality instrumentation for eddy covariance measurements on the top of our towers. The frequency of measurements are very high accuracy methods. 20 gears, it means 10 measurements 1 second per 1 second. Yeah, very high quality. It's very good for giving some mean value, 10 value or something. We can change 20 gears or some possible, yeah. And we are studying all components of carbons, for example, not only including this method includes also some process with evaporation, emission by plants, monoterpenes, or some substance is emitted also from trees. And also with changing of climate, this amount of carbon is increasing. And this figure shows that our regional scales of our measurements in central part of Yakutia. This is the left side of Lena River, and right side in opposite side. We have tower sites in both sides on the two bank of Lena River. For these measurements, we are using, this is our tower site. On the left side, we have 6 towers in this bank. In opposite side, 2 towers. And we're using some radio zone, also using some balloons, observation balloons, and using aircraft. We are upscaling these regions. We estimated on the scale 200, 400 kilometer by 200 kilometer. We estimated how much the changing of carbon greenhouses balance in this place. And now we found not so big difference. And in some tower from opposite side was remained from this place. And this is our tower site, near tower site. We have very good instrumentations. More than we have in one place near tower site, we have more than 300 sensors. Temperature, minimum temperature, soil moisture, solar radiation, etc. Too much, yeah. Yes, and all data is from all sensors is coming to one box for data logger, and after that we using our computer. We are trying to proceed our result. After that we can change with our data with foreign scientists, and we are carrying out investigation not only in terrestrial parts of our republic. We will carry out our investigation also on the river, hydrological, for estimation of hydrological flux. This figure shows our Lena River catchment experiments for estimation of how much of carbon and trace elements is delivered from Lena River and from main tributaries from Aldan and Vilu River to Arctic Oceans. And this is a result from our aircraft measurements. And also, finally, using our many 20-year time series experiments in central part of our republic, in the forest, and also our 14-year time series experiments in Tundra side. We estimated how much of carbon is sequestrated in this place. This figure shows the interannual variation in central parts. We can find very high interannual variability in this place in central Yakutia, in large forest. Depends of how to change climate parameters here, because interannual variability climatic also very high. Of course, and also uptake of carbon in central part, in central Yakutia is very high. Nevertheless, in southern part of Yakutia, in high productivity of forest, not so stored interannual variability, same like in Tundra side. This is very strong, depends, of course, in the case of Tundra with marine climate. In the case of in southern part of our republic, high productivity of forest with mountain climate. And we estimated how much, I already told, our forests uptake sink of carbon, sink, yeah. And you can find many years mean value for Tundra side and also for central Yakutia high moderate productivity of forest, and also high productivity of forest. And we make some speculative scheme which shows how much of all components of carbon is contributed to global carbon cycles. This one including trees, vegetation, including also soils, and so contribution of permafrost and so on. And also same result we obtained concerning of water, how much water is evaporated from this place, from each part of ecosystem with components of biomes. And also we make some results about how much of carbon is delivered from Lena River to Arctic oceans. Yeah, for example, from upper layer, it's more than 46% is delivered to Arctic oceans. And from this layer, from 100% is 68% is delivered from Aldan River. This is why, and 10% is delivered from Velu River. Why is this value is higher than in Velu? Because this place have another vegetation type, high productivity of trees, and also different geological structure. And about what will be in the future with our ecosystem, with our forests and also tundra. We made some extra explanation of our results, using our many years result. And now we can say it is some ideas, some hypotheses. Probably now is the period for decreasing of carbon sequestration sink in the forest. I already told we have mature forest. Mature forest is uptake not so much carbon than more young trees. And also very strong impact of global warming. Permafrost is melting and concentration a big amount of water, and some trees is died. some trees is remain from biosphere cycles. Nevertheless, in tundra side, now is the period for increasing uptake. What is the reason? Now we can find some very big and very strong expansion of shrubs in this place. And this species, trees, they have very high sequestration, high photosynthesis during long light periods. Yeah, and then about our result, we were obtained in the laboratory. I already told we cultivated our Yakutian and Japanese trees in climatic conditions, in the according scenarios, climatic scenarios, in condition of doubling CO2 concentration in plus 4 degrees centigrade. According to this result, we found very interesting result. The efficiency of water use and nitrogen use will be increased. It means it will be some process with activity of microorganisms. Of course, it's very good positive reactions, will be very good positive reaction for photosynthesis and for the growth of plants and for accumulation of carbon. And also will be, it will be very strong decomposition rate with formation of main elements like nitrogens. It will be very good for this process, for the productivity of our forest. Nevertheless, we have another phenomena is some process with perturbations. This mixing of plants, soils. If this will be accelerate this process, nitrogens and another big organs will be out of these cycles. In this process, if there will be this process, the photosynthesis rate and growth and carbon accumulation will be less. It's too bad. This is also one of the hypotheses. And using our many years results with within our European Union projects with 80 countries in Russia, we estimated how much of carbon is sequestrated in this plate. We estimated carbon budget for Russia. This is one. This experiment include main biomes: forest, grassland, tundra, wetland, and other. We use some many classification maps. Very difficult to use for forest classification map with 12% accuracy, and we using some 3 mathematical models: land ecosystem applied method, and also some inversion method using dynamic global vegetation models, and also our direct measurements using our tower. We estimated how much of carbon is sequestrated in this place in Russia for including 5 biomes. According to these results, this is how much of carbon is sequestrated in this place. Yes, for example, more than 1 billion tons of carbon every year is accumulated in this forest. It's very big. But, for example, if we will use some our expenditure with forest fire now, and also including some impact with insect, and also with problems with land use, and also with using some for using some forest products, for example, for logging or some cutting of forest, net bioproductivity will be decreased. Yeah, this value, for example. Now it's preliminary. It's experiment. Approximately 7 million carbon is sequestrated per year in Russia. This is very big value. In Kyoto Protocol, our Russia was prepared very small amount of sequestration. This value was only 160 million. This is 7. This is completely different. But if we will be use another expenditures, for example, using some how to much of water and lateral flux will be impact to these two carbon budgets, and how much of carbon will be used from forests, and how much of will be used this forest for fuel. We can find very small amount. Its amount is totally 200 million carbon per year. This is one of the, how to say, more in current time, these publications, our publication, one of the more reliable obtained result together with foreign scientists. Our investigations with international levels is very important, because we can, for the sailing of carbon between countries, we can prepare our data which we obtained within our international projects, not Russians. We're using some new methodologies for our studies. Thank you very much.
Thank you very much, Professor. Yes, there's one question, you see.
Yeah.
Well, thank you very much for the comprehensive scientific analysis and the statistics. So the fire do harm sufficiently the quality of the natural resources, and or even destroy them inevitably. So you reckon what is the biggest task, not for the establishment and or the political leaders, but for the society to prevent the possibility of the mass extinction and or the catastrophe in the nearest future?
You mean about forest or some?
Yes.
Huh?
All of the problems in the nearest future that we will have to face. What is the biggest task for the society right now?
Yeah. Okay. Yes, it's a good questions, but of course, in the future, of course, I already told you this: the period of decarbonizations, we lost big money because we had big forest fire. In this case, we was thinking about how to manage our forests using not only international experience, also using some Soviet experience. We must try to cultivate and some expand our forests. We must put big amount of money for conservation of forests. And also we were thinking about land use. Yes, it is also big problems. For example, for our republic, for example, in opposite side of our republic, in central parts, a lot of Allah's ecosystem with high productivity. It's not, it is without water. It is big problems. And we must thinking about also our management in agriculture. Nevertheless, with global warming, probably we expect an increasing of northern agriculture in this place. Yeah, agriculture will be moved to the north. Yeah, and also what? And also for using and for our data, for example, our scientific data, we must be very closer to society. We must find joint work, then expand and explain our work to stakeholders and policy makers. And they must thinking about our laws. Maybe better to change some laws. It's a big problem.
Thank you.
Yeah.
Thank you very much for this fantastic overview of what's going on in Republic of Sakha-Yakutia. And I have a rather practical question. How soon Yakutsk as a city will collapse under this melting problem of permafrost? And what's the probability in coming decades?
Yeah, very, very difficult for say. But nevertheless, I will try. Yeah, yes. I'm afraid it will be. We need long periods, of course. Problem, if will be too much water, this process will be very fast, like very quickly. It will be change urbanization ecosystem. Yeah, but very difficult to predict. Yeah, but you can find now some buildings which was destroyed, some basements, some destroyed completely. And also you can find many buildings in opposite side. Because in opposite side, too much capacity of permafrost. And it now is melting. And all big depressions became, for example, also some some field for aircraft measurements. Some airport is completely destroyed in opposite side. You can find small lakes.
Thank you very much.
Mm-hmm. But this process will be year by year increase.
So this is the quite inevitable.
Yeah.
Quite inevitable trend.
Yeah.
Okay. So we have more water.
Yeah.
After the forest, there will be more water, more lakes.
Yeah, sure.
Okay.
Yeah.
So that's what we understand.
Yeah.
And thank you very much. It was an absolutely wonderful presentation.
Oh, thank you.
Your research is extremely high tech, very sophisticated, hundreds of sensors, many people working in many different countries in a big network of researchers.
Yeah.
And this is a truly international global research and is a very high quality research, which has been doing, your team have been doing it for many years with your colleagues from Japan, United States, European Union, all other countries, Netherlands, and many other countries, which is absolutely wonderful because this is the example what the science can do and what the people of Yakutia can do as a scientist. So thank you very much, and very much hope that our young researchers will join your team.
Yeah, sure.
And start to do some wonderful research.
Few words. Now, using our international projects, we have some bachelor and master course programs, syllabus. We have international magister course with Hokkaido University, and also we have some more than 12 years experience for holding our summer and winter schools on climate change. Every year we invited students, but not limited in their age. We are invited to our stations. They are walking, they carry out investigations in our state, and also they prepared reports for us. It's really very good for young generations, for consist of new projects between our Russia. And of course, we need some education program with school children. Yeah, it's also very important. We must start our studies. We must find relative children for the science. Yeah, and we must start from maybe from kindergarten or from school. Yeah, and we will receive very positive results. We are waiting for your good cooperation in this field.
Thank you very much. So the Yes, Professor Maksimov, thank you very much. It's absolutely wonderful. And the Sakha Junior Science Academy obviously will have many more interesting projects. And with the help of Professor Maksimov, I think we're going to have a very interesting courses as well as the master classes, etc. So please do watch our sites and also the LK14, our special platform for you. So join us, and there will be lots of more fascinating and interesting experiences waiting for you ahead of your time at your schools, etc. Thank you very much. Thank you very much.